So now that we have seen how these reactions can produce particles or whatever, we're going to look at some specific examples so that we can see how these reactions are written. And so in radioactive decay, that's where that unstable nucleus emits radiation so it becomes more stable. And so when we write a nuclear equation, so this is synonymous with a chemical equation, we write the original nucleus with an arrow to the new nucleus, because it's going to form something new, plus what type of radiation it emitted. And so you've got to make sure that all your masses and your atomic numbers are equal on both sides of that arrow. So your products and your reactants. So we're doing conservation on this as well. So in an alpha emission, we're going to be decaying and we're giving off an alpha particle. So when it's emitting it, that means that it's going to be a product and it comes from an original nucleus. So uranium does this very, very typically. So you have uranium-238, okay, and so it has a mass number of 238 and it has 92 protons. All right, and so we are going to emit an alpha particle, and if you remember an alpha particle, we can write that as a helium atom 4/2. So it has a mass of 4 and a mass and an atomic number of 2. So when it creates a new atom, what it produces is thorium-234, which has a mass of 234 and a number of 90. Notice over here I have 2 plus 90 equals 92, and 234 plus 4 equals 238, so that I equal the 92 and the 238 that was on this side. So that's how I make sure that it's balanced. So let's look at an example of americium-241. Americium-241 also decays to form an alpha particle. So we're going to first say, okay, I've got americium-241, and I can look on my periodic table and find the AM has a 95 as an atomic number. It's going to emit an alpha particle, so I know that that's going to be the 4/2 helium, and then it's also going to be producing some type of other nucleus. So I know that I'm losing some things from that americium. So what's on the product side is going to have less mass and a lower number than what I started with. So what I do is I say, okay, I've got 241 on this side and I've got 4, and so what plus 4 is going to equal 241? And the answer to that is 237. Okay? Then I look at the atomic number. I've got 95 over here, and I've got a 2, and I know that because that's the alpha particle. So 2 plus what number equals 95? And that is 93 plus 2 equals 95. That's as simple as it gets to balance these nuclear equations. In a beta emission, same thing. If I'm doing an emission, then I am going to have producing that, giving that off from the original nucleus. So if I start off with carbon 14, I've got 14 and 6. I am emitting a beta particle, which is basically an electron. It has no mass, and it has a -1 charge. So the masses will be the same. So the masses will both be 14. So I'll have 0 plus what equals 14. so that's going to be a 14. And I have a 6 over here as the number, and a minus 1. So minus 1 plus what equals 6. All right, so if you remember from your algebra, that's going to be, if you move this over here, it's going to change sign, so 6 plus 1 equals 7. So it's going to be 14 over 7. So it's going to change from carbon to nitrogen, but it'll have the same mass. I know these are a little mind-blowing, aren't they? But you just go by the numbers and you'll get these correct. Positron emission, same thing as beta emission, except we have a positive electron this time. So if I start with 11 and 6, then I'm going to have 11 on the top because that's a 0, so that one's easy. And then the bottom number is going to be plus 1 plus something equals 5, right? So what am I going to, equals 6. I'm getting ahead of myself. So 6 minus 1 is 5 because 5 plus 1 equals 6, right? So this bottom number will have to be a 5. As I said, gamma emission is basically the decay of a nucleus just by emitting energy. And so they don't cause any change in the atomic number or the mass number. So notice that if I started out with 9943 technetium, I'm going to end up with that. And so what that is called is, plus the gamma ray. So what that's called is a metastable isotope, and basically it decays by gamma emission to a more stable, but it's still radioactive technetium-99. This one's a mind blower, so don't try to dwell on this one too much, but that's basically, it doesn't really change its mass or its number, but it is stabilizing itself. It's almost kind of like by releasing that energy, it kind of reorganizes so that it's in a more stable situation. A lot of times you're also having an alpha or a beta emission when you produce the energy, and so you're producing the energy in the form of the gamma ray. So if you're emitting a beta or an alpha particle, you're also emitting the gamma. So you're not going to see a lot of cases like technetium where it only emits a gamma ray. And so if you're in that situation, then for balancing purposes, you're going to have your 60 over 27 cobalt. You're doing a beta particle, which is your electron, so you know that 28 plus a negative 1 is going to equal 27. So that's why you got 28 over here, right? And then 60, because 0 is not going to change the mass. And then the gamma ray is not going to change either one of those. So this is just a good summary chart, and this is something that you might want to print on your card if you're afraid you're going to forget some of this, that you have an alpha, with alpha emission. And remember, when we just looked at emissions, and those emissions are all products. So when we've emitted one, the alpha particle is a helium, a beta is basically an electron with no mass, positron is a positive electron with no mass, and a gamma is a gamma ray.